Welcome back. Today we will be solving one LeetCode question, coin change. You are given an integer array coins representing coin of different denomination and an integer amount representing a total amount of money. Return the fewest, the minimum number of coins that you need to make up to that amount. If the amount of money cannot be made up by any combination of the coin, return back -1. You may assume that you have an infinite number of each kind of coin. Let's take a look at the example. Here we have the coin array with the value 1, 2, and 5, and the amount here is 11. What is the minimum or the fewest coin that we can make up to this amount if we have this coin array? So the answer is 3 because we use coin 5 2 times and coin 1 1 time. So 5 2 times 10, 10 plus 1 is 11. For this example, here we have the coin with the value 2 and the amount is 3. What is the fewest or the minimum coin that we can make up to this amount? The answer is -1 because we cannot use any coins in this array to make up to this amount. Here's the same example that we have the coin with the value 1 2 5 and the amount is 11 and the output is 3. This time we're gonna take a deeper look at how can we come up with the solution. First, we will initialize an array called dp. For this array, we will initialize it with the length of the amount here, like this. So now we have the dp array with the length of the amount here, plus 1. Why do we need plus 1? Say, right now we have from 1 until 11, and each of the element here is gonna represent each of the amount from 1 until 11. And we also need a base case when the amount is 0. So here the total length here is 12. Doing this, we effectively break the problem down into a smaller problem. So here, instead of thinking the amount is 11, we start with the amount is 0, and then amount is 1, amount is 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And for the coin here, instead of thinking we have the coin 1, 2, 5, let's say we only have the coin 1 here. So what is the minimum or the fewest coin that we can make up to this amount, which is 0 here? The answer is 0, because if we have 0 amount, we only need 0 coin to make the 0 amount. And what about when the amount is 1? So if we have 1 coin, what is the minimum coin that we can make up to the amount 1? The answer is 1, because we need 1 of the 1 coin here. What if the amount is 2? If we have 1 coin and the amount is 2, we will need 2 of the 1 coin here. So it's gonna be 2. What about when the amount is 3? What is the minimum coin that we can make up to this amount? If we have only 1 coin here, we need 3 of the 1 coin. So here is gonna be 3. And here is gonna be 4, 5, 6, 7, 8, 9, 10, and 11. I will also put it here when we have coin equal 1. So what about when we have coin 1 and coin 2 in our disposal? So if we have coin 1 and coin 2, what is the minimum or the fewest amount that we can make up to the amount 0? The answer is still 0. And what about 1? If we have 1 coin and 2 coin, what is the fewest coin that we can make up to 1? The answer is we can simply take 1 of the 1 coin. So this one is going to be 1. What about 2? For 2, if we have 1 and 2, we take 1 of the 2 coin. Here's going to be 1. What about 3? 3, we're going to take 1 of the 1 coin and 1 of the 2 coins. So this one's going to be 2 coins. What about 4? 4, we can simply take 2 of the 2 coin. 5, we're going to take 2 of the 2 coin and 1 of the 1 coin. So it's going to be 3. What about 6? 6 here, we can take 3 of the 2 coin. It's going to be 3. 7, it's going to be 4. 8 is going to be 4. And 9 is going to be 5. And 10 is going to be 5. And 11 is going to be 6. This is when we have coin equal 1 and 2. What about when we have the whole array here? So when we have the coin 1, 2, and 5 at our disposal, what is the minimum coin that we can make up to this amount, the 0 amount here? The answer is still 0. What about 1? For 1, If we have the coin 1, 2, 5, we can just take one of the one coin to make up to the amount 1. So this one's gonna be 1 also, and 2 is gonna be 1 also, and 3 is gonna be 2 also. What about 4? 4 is gonna be 2. What about 5? If we have the coin 1, 2, 5, what is the fewest coin that we can make up to the amount 5? The answer is 1. Why? Because we can take one of the 5 coin. What about 6? 6 is gonna be 2. We take one of the 5 coin and one of the 1 coin. What about 7? 7 is gonna be 2. We take one of the 5 coin and one of the 2 coin. What about 8? 8 is gonna be 3. We take one of the 5 coin, one of the 2 coin, and one of the 1 coin. What about 9? 9 is gonna be 3. We take one of the 5 coin and 2 of the 2 coin. What about 10? 10 is gonna be 2. We take 2 of the 5 coin. And what about 11? 11 is gonna be 3. We take 2 of the 5 coin and 1 of the 1 coin. So here is 3. And the answer is 3. You can see here 3 and 3 here. I will also denote it here when we have coin equal 1, 2, and 5. Do you see the pattern here? The pattern to get the final solution? Here we see that when our coin array equal 1 with the amount 0, we have 0. And if we have the coin 1 and 2 to make up with the 0 amount, we have the 0. And also if we have the coin 1, 2, 5 to make up with the 0 amount, we still have 0. So we can deduct that our DP array here for the first element is always gonna be 0 because it is gonna be our base case. Here we can see that if the amount here is bigger than the coin, then we can just skip it because there's no way that we can make up to that amount. Say we have the coin 5 and we want to make up to the amount of 2. How can we choose the 5 coin to make up to the amount of 2? There's no way. So we can just skip this amount. So another deduction that we get is if coin is bigger than amount, then we skip. Let me clean up our example here a little bit. So here we don't need to put this 2. And we can simply start from 2. Because our coin here is 2, we can just start from the amount of 2. And here we can just delete everything here. So when we have coin 5, we skip any amount that is smaller than the coin. So 0, 1, 2, 3, 4 are smaller than 5. And we skip it until we reach a 5. Also, when we have coin 1 here, we can see that each of the value change, each of the value add by 1. So here is 1, 2, 3. Each of the value increase by 1 until the end here. And if we have the coin 1 and 2, we can see that each of the value is either stay the same or increase by 1. And here if we have the coin 1, 2, and 5, we can see that each of the value stay the same or increase by 1 or also decrease. So from this observation, we kind of know that the value will be increased by 1 or we take the minimum of something. So here I'm gonna put dpi equal something plus 1 or the min of something. When we have the coin 1 and 2, we know that we skip 0, 1 and then we start with the 2 here. And the value here is 1. So when you have 2 coins and you want to make up to the amount of 2, so the amount is 2 minus 2 coins, so you have the 0 amount. And at the 0 amount, you have the 0 value. And how can we get to 1 here? You have to plus 1. So 2 minus 2 equals 0. And then we take the value here and add 1. And then we get this value. And here when we want to make up to the amount of 3, so we use 3 minus 2 equal 1. And 1 here, we look back at our previous amount. So when we have the amount 1, we have the value 1. So 1 plus 1 equal 2. So what about 4? If we want to make up to the amount of 4, we use 4 minus the 2 coin, and then we get to the index 2, or the amount 2. And then we look up at the amount 2. At the amount 2, we have the value 1. So 1 plus 1 equal 2. What about 5? Here 5 minus 2 is going to be 3. So at the amount 3, we have the value of 2. 2 plus 1 equal 3. Next, 6 here. 6 minus 2 is going to be 4. At index 4 or at the amount of 4, we have the value of 2. And 2 plus 1 is equal 3. And next 7. 7 minus 2 is equal 5. And 5 we have the value 3. 3 plus 1 equal 4. And what about 8? 8 minus 2 equals 6. At the index 6 or at the amount of 6, we have the value 3. 3 plus 1 equals 4. What about 9? 9 minus 2 equals 7. At the amount 7, we have the value 4. And 4 plus 1 is equal 5. What about 10? 10 here minus 2 equals 8. And at the amount of 8 or the index 8, we have the value 4. 4 plus 1 equals 5. And what about 11? 11 minus 2 equals 9. At the index 9, we have 5 value. And then 5 plus 1 equals 6. So from the observation, we can say that dpi will be equal to dp, the amount, minus coin. This will get us to the previous index and then plus 1. Now let's move to when we have the coin 1, 2, and 5. We know that if we have 5 coin here, we skip all the value that is smaller than 5 and then we start from the 5 here. So here, according to our formula, we know that we use the amount, which is 5. 5 minus 5 equals 0. And at the amount 0 or at the index 0, we have the 0 value. And the 0 value plus 1, we have 1 here as the value. Let me also delete this one. Next, when the amount is 6, we use 6 minus 5 equals 1. And at the index 1, we have the value 1. 1 plus 1 equals 2. Next, 7. 7 minus 5 equals 2. 2 here we have 1. 1 plus 1 equals 2. Next, we have 8. 8 minus 5 equals 3. At the index 3 or at the amount of 3, we have the value of 2. 2 here plus 1 equals 3. Next, 9. 9 minus 5 equals 4. At the index 4, at the amount of 4, we have 2 as the value. 2 plus 1 is 3. So here is 3. Next, 10. 10 minus 5 equals 5. At the index 5, we have the value as 1. And 1 plus 1 equals 2. And next, here we have 11. 11 minus 5 equals 6. At the index 6, we have 2 as the value. And then we add 1, we have 3 as the final answer here. And we also can see that each of the column, each of the index here, we only take the smallest value as the final answer here. So here we have 11, 6, and then 3. 10, 5, and 2. 9, 5, and 3. So here, dpi is going to be min of this amount and also the current dp. So if the new calculated amount is bigger than our current amount, we just take the current amount because the goal here is to get the fewest or the minimum coin that we can make up to the amount. Let's code out the solution. So here I will initialize an array called dp equal to new array with the amount plus 1, and I will fill each of the index with the value of infinity. So this will effectively create the array with the length of amount plus 1, and then each of the index will have the value of infinity. The reason why I put infinity here, I just want to use the biggest number, and then we can just compare by using math.min to get the minimum fewest coin here. And we also know that at the first index is gonna be 0. And then we loop through each of the coin. And for each of the coin, you want to go through the entire dp array here. Let's say I equal coin. And then I smaller than dp.length I plus plus. The reason why we start from the coin, we know that if the coin here is bigger than the amount is bigger than the I, we cannot make the change. So we have to skip it until I here, the amount here is bigger or equal to the coin. Here I will initialize a variable called previous value equal to dp I minus coin. And then we want to update our current dp, current array, current amount here equal to previous value plus 1. And we also want to take the minimum between the current amount that we have with the new calculation here. So math.min, and after that we return dp dp.length minus 1. This is going to be our answer, but remember we initialize our dp here with the infinity, so we check if the last value here is equal to infinity. If it is equal to the infinity, we know that we have never updated the solution. We don't have any coin that can make up to that amount. Then we can just return -1 here. If it is not equal to infinity, we know that we somehow kind of update our solution for each of the amount. So here we can simply return back the dp.length minus 1. Let's check the result. What is the time complexity for our implementation? The time complexity is going to be O of C time n. C here is the length of the coin that we have for the outer loop, and n here is the amount, which is the inner loop here. What about space? Space is going to be O of n, because we have to create an array with the length of the amount here. Hope you guys enjoyed it. See you next time.